Right, my name's Neil Armitage. I'm a senior DevOps engineer for VMware. I've been in IT coming up to 30 years now. Started off in mainframes and various DBA jobs, developers, everything around that. I'm technically based in Palo Alto for VMware, but I actually live in the Scottish Highlands. So it's a fairly long commute, but I don't go there very often. Right, a little bit of background to this talk. In October 2014, VMware acquired the assets of Continuant Inc. I have to be careful with the legal bit around that, because they didn't actually acquire the company, they acquired some of the assets for some reason. The Continuant team joined VMware's hybrid cloud business unit, which 2 years ago was very focused on promoting vCloud Air and bringing new services to vCloud Air. And we were brought in to bring in database as a service to vCloud Air, because at the time it was the one thing they were very much missing. And they couldn't recruit staff to do it, so they decided to just buy us. As part of this, we needed to migrate all of the Continuant test environments, QA environments, from a rather large mix of outsourced environments into an internal VMware environment. And it had to be very non-disruptive. While I was on the flight over here, something happened within Continuant which has changed some of my later slides. I've gone back and updated as many as possible, but some of the slides might be slightly incorrect. Hopefully I've fixed most of them. I was expecting the announcement to be next week, and they brought it forward a week. So what was Continuant? We had two major products, a commercial product called Continuant Tungsten, which focused on MySQL asynchronous clustering. We had an open source Tungsten replicator, which basically moved data around from MySQL to MySQL, Oracle to MySQL. MySQL to Hadoop was quite a popular one for us, and MySQL to Redshift. We were under the covers of an awful lot of companies, and no one actually knew we existed. eBay uses our Hadoop replication in most of their systems, and quite a few big companies do as well. I used to work in the UK. The Financial Times runs on all of our software, so their website. We were essentially 20 people dispersed around the world. We had a team in France, some out in California. And it's been a bit of a shock going from 20 people to 18,000 in VMware, and now 140,000 as part of the Dell EMC thing. Right, we had servers sort of randomly dotted around the world. We had some in AWS West, AWS East, some in Rackspace in Dallas, some in a company called Hetzner in Germany, some in online.net in France, and some in Singapore for some obscure reason. There was about 50 physical hosts dotted around the world. There's customer-facing website, some Jenkins environments, some test and QA clusters, and a Puppet master, strangely enough. Some of these have been knocking around for almost 10 years. Some were under Puppet control, some weren't. And they were a mixture of CentOS 4 upwards, various Ubuntu variations. We had a Jenkins CI pipeline running in AWS at the time, which was running against various AWS services. It had about 200 test jobs. We looked at various tools when we were looking at automation. When we looked about 4 years ago, and Puppet and Chef were the two big players then. We tried the two together. Puppet we got running in about an hour. I don't think we ever actually got Chef properly running. So we started using Puppet. I looked at Ansible about 2 years ago, and it never really made an awful lot of sense to me. I prefer a centralized server pushing stuff out. So. Considering this conference, I will admit to being I'm not a fanboy of Puppet. It works, it's a tool. To me, it's a tool that works really well for the use cases we had. I'm also not an amazing VMware fanboy at the moment either. So pre-migration, we had some of our machines already puppetized. We got hacked several times because our infrastructure was very old. It had never been properly maintained or set up. We were running quite a few Bitcoin miners, I found out one day. When our AWS bill came in, someone had got in and decided to borrow all of our servers. So we used Puppet initially to set up firewalls on all the nodes. Locked down all the users, disabled routes, moved SSH to a new port, set up a jump host to jump through, standard stuff. And we did some work on a Puppet module for installing our software, which we've now forked off into a separate open source module. And it's become quite useful for our customers. So the work we did for this is fed back to our customer deployments. Why did we migrate? Strangely enough, at the time, VMware were not keen on paying our AWS bill. This has sort of changed in the last couple of weeks because we're now best friends. But 2 years ago, they were the dreaded enemy. But we were dealing with multiple vendors. Hetzner in France preferred to speak in German. Online.net preferred French. AWS never spoke to us. So we wanted to consolidate in one place. And some of the physical hardware we had was absolutely obsolete. We had around 40 QA hosts running, and the QA team wanted at least 400. They wanted thousands, but we negotiated it down to about 400 at some point. We were using Subversion, while VMware standards is to use Git. So we had to move to their GitHub, their internal Git repositories. We were moving into a lovely, shiny environment that VMware had nicely brought for us. It was 29 big blades, which had about 300 terabyte of disk, and it was all clustered into what's called a vSAN cluster. We also had 70 more physical hosts. The only problem was they're in a VMware data center. The only way out was on port 80 or 443. There was no SSH outbound. There was absolutely nothing inbound. So it made the migration a bit more challenging. Just a quick definition of vSAN. If you're running ESX hosts, you can actually cluster all of the disks in the local machine to form a single data store which is shared, and it's redundant, so you can lose an ESX node and it's replicated across all the nodes. It's a very powerful bit of software when it works properly. We had a lot of constraints in this. We had committed to ship new releases of our products to our customers who were not particularly happy that VMware had brought us, because we prided ourselves on at the time we were very customer-focused, interactive. The customers could call me directly if they had a problem. We had that relationship, which they thought they were going to lose with VMware. So basically, breaking the QA environment was not on the cards. And add to the fun, I'd never used vCenter before. It was totally new to me. Our whole division in VMware were all new recruits, so we had very little experience within the team on anything about vCenter. So it was a bit of a risk. So we basically came up with a plan. We'd leave everything running how it was. We'd build the new environment, and we'd run everything in parallel. And hopefully, at the end, everything will be the same, and we can just cut over. But it meant we kept two environments running in parallel. And we actually delivered the product releases out of the existing environment while I was migrating stuff to the new environment. So basically, we clustered 29 hosts into a single vCenter. We created a lovely big vCenter cluster of about 300 odd terabytes. I deployed a Puppet master and a Puppet DB. And I started working on the new modules. 2 days later, I came along. All the VMs had just disappeared. The vCenter cluster had failed in a catastrophic way. Someone in VMware purchasing had brought SSDs that were not compatible with VMware software. We never found out who actually authorized the purchase. And it took the engineering team about 2 weeks to diagnose what was wrong. But if you buy SSDs to run vSAN, they have to have a particular model and firmware version, which we didn't have. So I then went and borrowed a VNX SAN, which is quite convenient. Being owned by EMC, you can get hold of this stuff fairly easily. Redeployed everything onto the SAN. And 2 days later, it was still there. So, which was lucky. We still haven't got the SSDs replaced. We actually use all the local disks as local storage now. So basically, we deployed the initial architecture using Puppet. I'm an awful coward. I don't control ETH0 with Puppet. I've seen Puppet go a bit mad and screw up network configurations and get you locked out of the host. So anything ETH1, I use Puppet, no problem at all, but I don't let Puppet touch the external Ethernet connections. And because we're in VMware world, we have a physical network at the top, and then everything underneath is a virtual network using NSX and products like that, which actually work really well. Can be fairly negative about VMware, but their stack is absolutely amazing when it works properly. So we then started devising Puppet modules. What we have is a base class, which has all the developers' user accounts, SSH keys, so all the machines have got the same access on them. We run a mixture of CentOS and Ubuntu hosts for testing. We also do SUSE and Solaris now as well. So the same Puppet modules will deploy on all of those operating systems. It sets up remote syslogin, NTP, which is amazingly important in VMware world because it took me a while to work out there was no route out to connect to the default NTP servers that CentOS was installing because the ports were blocked. And it sets up Nagios monitoring for all of the hosts. And it controls what we class as the internal network. We've got lots of modules as well. We automatically install and configure MySQL, Oracle, Vertica, MongoDB, and there's about 3 or 4 different flavors of MySQL we install with Puppet as well. So if the QA guy wants a CentOS server running Oracle 11 and MySQL Percona 5.7, we can do all that with a Puppet module for him. So we've got modules to create Jenkins and Nagios monitoring by default, and they rely very heavily on exported resources from the Puppet module. So it basically means I don't have to set up Nagios monitoring. Puppet will do it for me. So exported resources. This is the definition from the Puppet manual. It's basically saying it's the desired state for a resort, but it's not on the host you're configuring. It's going to be on another host. So this is possibly a better description. So the VM runs Puppet. It passes some form of information back to the Puppet master. That Puppet master stores that information in the Puppet DB for some use in the future. When that information is used by another Puppet module, the Puppet master will suck it out of the Puppet database and pass it on to the host. So in this example, it's setting up DNS. So this is an exported resource for a DNS record. This will run on the host you're configuring, but it won't actually do anything on that host. All it will do is pass that record back to the Puppet DB. And then when you define your name servers, right at the very bottom, it's pulling all those A records in from the Puppet database. So this one is just exporting it, and then this one is using it at the bottom. It's pulling all those records out. So it's a way of automatically configuring a DNS server in this case. So I'm now going to try and do a demo, whether this will work or not. I've got essentially a Puppet master, a standard web tier. So I've got a web server, I've got MySQL, and I've got a DNS server. The Puppet master was just set up using the standard Puppet Labs modules. So it configures itself, it configures Puppet DB by default. I'm very dubious about touching the screen. This was all set up and we had to reboot the machine. I've actually been really lazy and I've actually pre-recorded the demo because I've used enough Wi-Fi's in conferences over the years. So basically on the Puppet master, we've got the basic configuration for all of the nodes. We recording's a bit slow. So essentially, we've got a web server which is exporting its DNS name, and then we've got a DNS server which is going to import those records. So we go into the MySQL server first and run Puppet. And it will just run a normal Puppet run. It's using the Puppet Labs MySQL module to install MySQL. So that's installed. And MySQL is running. It's fairly standard. And we'll do the same on the web server, and it will install the Apache module. And this again is using just the standard Puppet Labs Apache module. So Apache is running on that machine. Now we go to the DNS server, and when this runs, it's going to retrieve all the information about the other nodes that it's already installed. Set up a DNS server. For some reason, this actually fails, but it does actually. So it's actually got the 2 records in there for the MySQL machines. Slightly worrying for a minute. So we then built out multiple clusters, each running various nodes. Each node was defined in a Puppet manifest in a rather large site.pp, because for some reason I couldn't get this working correctly with higher data. It was that node data thing didn't translate very well into JSON for some reason. So each node we have a cluster of nodes which has the IP details and which version of MySQL to install on it. And from this, Puppet will configure all the network interfaces, EC2 hosts, which is needed. Same module again, but in this case it's installed in Oracle. So it will install Oracle, configure it to how we needed it as well. In this case it has to install Oracle off an NFS mount because for legal reasons we had to stage the binaries somewhere else. I can't remember why. We had some problem with Oracle. We supported various MySQL flavors, Oracle 12, 11G, Vertica, Hadoop. And we did Jenkins configuration. This probably was the most useful thing. We had several hundred tests in Jenkins. When they were running on old hardware, each test would be hard-coded to run on a specific cluster. So it was very inflexible, and if that hardware went down, we couldn't run the tests. So in the new environment, we basically just specify, the test says, actually I'll just show it. The test says in a label, in this case, I want CentOS 6, C6 nodes, and I need 6 of them. And Jenkins will allocate a set of nodes automatically to that job, and it will run away. So if I lose a cluster, it doesn't matter. Jenkins will just pick another one. In this case, there was 8 clusters running that met that criteria. So Puppet would create the Jenkins slaves automatically when it saw that a new cluster got deployed through exported resources. It would know to create a Jenkins slave for that new cluster. Puppet would insert metadata into that slave, specifying the host names that consisted in that cluster. So Puppet would automatically create the slave. Nice thing in Jenkins is a slave is just a chunk of XML. So Puppet can quite happily create that XML definition. And Puppet would automatically create a file on that slave telling Jenkins what nodes were underneath that slave. So if I needed to change nodes, Puppet would just automatically update these files. And because I'm using automatic DNS, I can use DNS names in there as well. So in the we deployed the nodes using PowerShell, which is quite powerful in VMware world. When we initially did this, it meant we had to use Windows machines to run the deployments, but PowerShell naturally runs on Macs and Linux machines natively now. That would essentially clone a VM and shoot it out into the vSphere environment. The nodes booted up, ran Puppet automatically. We just automatically signed the certs because it was a completely closed environment. No one could get into it. So internal DNS was set correctly by the Puppet. So the node was configured by the Puppet master. Monitoring was automatically set in Nagios by Puppet using exported resources. The DNS was set, and the cluster registered itself with Jenkins. So at the end of the day, we deployed around 1,000 nodes this way. And all of it was generally automatic. So once we configured it in site.pp, set the IPs we wanted to use in the IP ranges, these nodes would just go away and build themselves. We copied the tests across. We ran in parallel for about a month. In the old environment, it used to take about a day to run a test cycle. In the new, it took about an hour. So it meant the developers could run more cycles and the software, in theory, got better. Then we killed off the old environment, which was a very good day for a lot of us. Once we started working in VMware, we had to start using Windows and SQL Server because one of the initial pushes in vCloud Air was to do database as a service with SQL Server. We were going to use, up to this point, everything has been using open source Puppet. So we looked at Puppet Enterprise at this point to get the SQL Server module. We never actually got it because it took about 6 months for someone in VMware to actually approve the purchase order. It was a bit of a shock. Before, I would have just put it on my credit card and billed it back when we were a small company. To get a £30,000 PO approved took 6 months. The future. On May this year, VMware end-of-lifed Continuum products. So we never actually really got to use the software. As of Monday morning, Continuum was actually spun back into a separate company. VMware decided they no longer wanted us. I'm actually staying with VMware. I haven't gone with the new company. But this happened essentially while I was in the plane flying over. So at the moment, I'm actually working with the staff that moved to Continuum to migrate it all back to AWS. So, sort of slightly insane. We're wondering if next year I'll be doing another talk, doing the migration the other way. So essentially, about 75% of all the VMs have now been completely decommissioned. So, and essentially we're using the things I've learned on this project to move forward into the new project that I'm working on. And most of us are now working on VMware's new disaster recovery solution. So, lessons learned. This is the most important bit for us. We spent an awful lot of time getting set up and running. But now everything is simple. We spent probably 6 months getting going, and now, because all the modules are there, I don't like using the word I have very little work, but I don't do an awful lot of deployment work anymore. It's automatic. So do not ever go in and hack a server. I'll repeat that because it's so painful when someone does it and breaks your Puppet modules and you have to log on to 1,000 machines to change them all back. And especially because I work in a distributed environment, I work from home, I can't go around and speak to them when they do it. So, we were running Puppet 3.7 and PuppetDB started leaking memory like there was no tomorrow. And I think I ended up allocating about 32 gig of JVM memory for it. So, and a cron job to restart it every Sunday morning. We're running 4.0 now on the new project, but I haven't run it in any scale, so I'm hoping it's better. So, push everything into source control. We use Git, so I push into Git. The Puppet server does a Git pull every 10 minutes to update itself. So. And any questions? Yes. Sorry, I can't actually see because there's lights everywhere.
Hey there, I'm just curious what you were using to manage your Oracle installations, module from the Forge or something custom written?
The question was about managing Oracle. There was a module on Puppet. I think we found it on GitHub that did most of what we wanted. We forked it. It's still publicly available on GitHub, and it seems to work quite well for us. So I think it's on the continuant. There is a continuant GitHub. I don't know the exact status of it this morning because it's been transferred to the new continuant in the last couple of days, but it should still be there. So, yes.
I was wondering the same thing about your Hadoop clusters. How did you all do the migration with those?
Sorry, I couldn't hear that.
I was wondering the same thing about your Hadoop clusters.
Yeah.
What did you all do? How did you all do those? Were those also the modules you found on GitHub, or what did you all do?
It's the same question about Hadoop modules. I think one of the guys actually wrote his own module. And again, that will be on the continuing GitHub site because we use it for commercial deployments as well. A lot of what we did for internal work has been pushed into our open source stuff because it did allow our customers to deploy proof of concept clusters quite quickly. So we pushed all the good stuff out into GitHub. We've got some stuff we're not allowed to push out, but because VMware has lots of lawyers. So. Any other questions? All these slides and that are on my GitHub thing and the demos and everything I did for the setup. So, okay, great. Enjoy the rest of the conference.